Hi, I'm Jeremy Scannell. I'm a Senior Solutions Architect with AWS. Been here about 3.5 years now. We work with energy customers, so we're oil and gas, utilities, renewables, nuclear, etc. So we work with those customers to help them in their journey on AWS, helping them modernize, migrate, all ends. So we're here, we're going to talk about Bedrock multi-agent orchestration. So Salman's going to kind of give a really good intro to agents, orchestration of multi-agents, the Bedrock service, and then kind of like the final half, I'll go over, just show a demo, show some code, show the agents, show them working together to help modernize an application and get it running in AWS. Okay.
Hi, I'm Salman. Am I audible or should we use the mic?
Okay. Your voice is definitely carried.
Yeah, all right. Hi, I'm Salman, also another SA in energy. Jeremy and I are dedicated to Xterra here in South Florida, and so he kind of covered what we do. Today we're going to be talking about agents. So before we get started, just kind of question, I think I saw somebody with like an agent shirt on. How many people have played around or built stuff with agents before? Okay, we got some folks. Yeah, regardless of whatever platform that you've built, you've done your creation, testing, or debugging on, there's some challenges, and so we're going to talk today about how Bedrock makes it easy to use single and multi-agents to solve your different kinds of problems, and then we'll have a nice little demo at the end that showcases everything. To sort of level set before we get started, agents are, we define them to be intelligent systems that can leverage large language models to interact with end users. So they're capable of planning, reasoning, and acting in a dynamic and multi-step manner to execute your workflows. So when many people build agents, they grant them access to things like your enterprise data systems, your documents, your corporate wikis, databases, whatever contextual information that agent needs to be able to work. So you can also configure the agent to use tools like the ability to search the web, to access your APIs, memories, guardrails, all these different things. Don't worry if you're not familiar with all of these features, we'll sort of talk through some of them. But to help drive the point home, let's start with just like a simple example. So here, let's suppose that you want to build a weather agent to help you figure out what the weather is. You're tired of opening up the weather app. So the structure of it might look something like this. So you'll have your LLM, right, which you've probably talked to. This is the Claude, Sonnets, Haikus, the DeepSeeks. And then behind that, you set up your agent, which is going to solve that specific problem. In this case, it's figuring out the weather. And so the agent has this API in the background and knows how to talk to it. So the flow will look like this. You go and you talk to your LLM. Your LLM will say, hey, I don't know what the weather is, but I do know an agent that does. You'll go talk to the agent, and then it'll feed you back the information. The reason this is cool is because it allows you to dynamically solve tasks without having to build your own custom LLMs. The most expensive piece of this is this, right? You don't want to end up doing this. It takes hundreds of millions of dollars or billions of dollars to build. And so the agent allows you to be able to dynamically do that in the back. And then also the second benefit is that it doesn't tie you to a specific LLM. You can sort of swap these LLMs out, and a bunch of new models are coming out, and so let's take advantage of the newest models. So now let's talk a little bit about Amazon Bedrock. Has anyone used it before? Okay, one person. So for folks that aren't familiar with it, it's a fully managed service that provides access to high-performing foundation models from a bunch of AI companies. So you have models from like Anthropic, like Claude, Sonnet, Haiku, Opus. You have R1, and then you have, of course, the AWS Nova models as well. It provides an easy interface to import your own custom models as well. You can do some fine-tuning. You can do some. You can distill your models in there, and then there's a bunch of additional tools in there, like knowledge bases, if you want to have some contextual information for your agents. You can have guardrails if you want to prevent your applications from being used a certain way. You can have flows, and then agents. And today we're going to really focus on this agent piece. And then of course there's like everything that's built on AWS is underpinned by this enterprise-grade security. So essentially, it's just an easy way to build your generative AI applications. So let's take the same example earlier. I built this out in Bedrock in like 5 minutes, right? I built an agent, and then I had Claude write the code for how to get weather from the API, put it in there, and then I just asked my LLM, what's the weather, and then it spits that back. If you want to sort of double click in this, we have a feature called trace, because these are non-deterministic models, and so you want to have the visibility to see what's happening underneath. So there's this feature in Bedrock called trace that lets you see what the model is doing in the background. So you can see here it's thinking, in order to get the weather, I'm going to have to use the provided function, that agent. It does that, and then it returns the response here. So we talked to a lot of generative AI customers, and the top 3 things that they've told us that they want is help in terms, so their use cases are diverse, they're industry specific, they're multifaceted, they're complex, and so there's a lot of advanced orchestration that has to happen in the background for them to achieve their goals. And so they want a solution that can let them do that. They also want to move pretty quick. A lot of expertise is required when you're working specifically with agents in terms of scaling them, so you get this lengthy development cycle when you're launching agents. And so a lot of companies aren't in the business of agents, right? They want to sort of abstract that away and focus on what's valuable to them. They want ready to use out-of-the-box solutions that can help them move faster. And then the last thing is this idea of robust and scalable solutions. So they want to manage, when there's new models are released, they want this easy click and drag thing where they can switch in those models. They want higher order levels of abstraction to manage the agentic primitives so that they can just focus on their business value. So this is why we created Bedrock Agents. This delivers the foundational blocks for customers to build their own agentic applications. On Bedrock, you can choose from a variety of the different models that we talked about. You can select your memory retention preferences, your knowledge bases, your guardrails, and then you can provide additional tools to your agents to be able to do their jobs in a custom manner through like Lambdas. We also, you just saw the trace feature, which lets you look at what's happening underneath. And then the last feature, which we're going to really focus on, is this idea of hierarchical multi-agent collaboration. So it's sort of intuitive, right? Like if you look at the name, but basically it's just multiple autonomous agents that are interacting, cooperating, sometimes competing for an outcome. So why? I guess let's start with the why, right? Why did these agents need to talk to each other? Why can't I just make a really good agent and then it does the stuff that I want? Well, many customers have told us that they're reaching the limitations on the scope and the scale of problems that they can solve when they're working with individual agents. And so the obvious answer here might be, well, just get more agents, right? But I think the less intuitive piece is they have to be really good at talking to each other. And so just like if you have like a human team and you have too much work for one person and you hire more and more people, you're eventually going to have some sort of central management that needs to delegate tasks and organize to make sure that there's a central vision and stuff is getting done, right? And so this is essentially what that solution is. And customers asked us for this managed solution to allow them to orchestrate their agents, and so that's what we built. The main benefit here is twofold. So you have this first, which is problem solving and accuracy. So it means that you can work on more complex problems because these agents can all do different domain-specific things, and they can talk together really well. And then you have also velocity and scalability, because other people in your organization can now deploy these solutions that you built without needing to know how to build them or to deploy them themselves, right? So you have this velocity. And then of course it's secure because it's built on AWS. So let's kind of get into an example, which will, I think, sort of crystallize this point. So we had the weather agent, right, that we wanted to build out in Bedrock. So if we look at what I did underneath the hood, it looks something like this. We have action, these are called action groups. They basically determine what you want your agent to do. So there are some things like get weather, get precipitation, get the feels like temperature, and then in the background, you have a microservice, right, could be Lambda, whatever, that's talking to that API, getting the information back, and then feeding it to you. So let's say that we had this idea, it worked well, and now we want to expand it out into something that plans out like a fun weekend for us. So what we might do is we might say, okay, so let me add a knowledge base that is a list of stuff that I like to do, right? And that's connected to, you can see a database there. There's a bunch of things I like to do. The agent now knows the weather, it knows what I like to do, it can give me some stuff that makes sense for this weekend. And then this works really well, and so we're like, okay, cool. Let me add even more stuff so that like it can maybe get live events that are happening in my city. So what we do is we add another action group, right, that says, get me the concerts, get me comedy that's happening, sports. And then you have the same structure in the background that is talking to some sort of Eventbrite API or just some event API that can give you that information. So now we have a pretty good weekend, fun planner that can figure out the weather, it knows what we like, and it knows what's happening in the city, right? And so we can plan a great weekend for us. So at this point, we're really happy with our application, and we're like, there might be like a business idea here, right? So let's hire a developer, and let's just add a bunch of features to make this really cool. So we add a bunch of features. We tell that developer, hey, could you add the ability to see what restaurants are available in my city, to make reservations for me, and then I'll also upload my budget so that you know the constraints that I have, so that you can pick restaurants that make sense for me. And you have all of these features in your agent, and then you go to test it out, and it doesn't work, right? You're getting inconsistent responses, you're getting, it's very slow, sometimes it doesn't get anything back, and you're sort of confused. If you've built applications before, you probably identified the problem pretty quickly, and that's that you built a monolithic application, right? As the modern applications are built in a loosely coupled manner, which means legacy applications are built in, let me start there, a tightly coupled manner, right? The problem with that is that you have this massive single point of failure because everything is sort of happening in this one, bubble. And so when you when you decouple this, you decrease the complexity and you allow yourself to, allow for things to work better, right? So in our example, our code got really complicated. And so maybe we need really specific prompts in order to get the AI to spit out what we want. And then hallucinations are more likely to happen because the AI is getting confused. It might call the wrong tools for certain tasks. It might pass in wrong arguments. And so you're getting a bunch of inconsistent responses. Or what you might have to do is swap in that LLM at the front and make it even like a bigger LLM, right? Like go from like a sonnet or a haiku, which is cheaper, into like an opus in order for the LLM to be smarter, which means that you're gonna pay a lot more money. And if it fails, then it has to retry, and so it's just gonna end up costing you a lot of money, right? This is not a good way to scale out your agentic workflows. So how can we solve this? Well, one solution might be, okay, so let's just separate it up. Let's create a weather app for our weather. So I will go to that and I'll say, hey, what's the weather? Okay, the weather is 84 degrees. Okay, cool. Let me open my events app. Hey, what's going on? The Heat are playing Denver's in the finals. That one's a little aspirational. We had a rough season, but maybe next year. But so that's happening. And then you say, okay, I might want to like stop and get some food. Okay, let me open my third app and say, how much money do I have? Okay, I have $315. So, all right, I can kind of put together a plan in my brain, or maybe feed this information to an LLM to do it. And this is not like a super great solution. There are a few benefits, right? Like, first, the agents do scale independently, so that means that they're less likely to fail, right? Like, they all do very specific things, and so they're not going to hallucinate as much. And then this is just also like really easy to do, right? Because there are 3 separate applications that do very specific things, and so you can use really cheap models in front of it and kind of just get them out. And then accuracy would also increase because, like I said, they're just smaller applications, so you're gonna have less hallucination. But ultimately, like, this isn't a great solution. The whole point of this application was to have this one-stop shop where you could plan out your weekends. Now you're clicking through like a ton of tabs, and then as you add more features, you're gonna have like, more and more applications. And so this is just scaling into kind of a nightmare. You are gonna get this really splintered user experience where you have a bunch of applications that people have to click in between. Orchestrating that at sort of like a higher level, if you want to have a single view, is kind of just difficult to do yourself, right? So you have a bunch of these separate applications, and then you're going to build another layer of abstraction above it that kind of talks to that underneath it. It's really complicated to figure out how to do that yourself, especially if you're not in the business of agents. And ultimately, the central problem is still not solved, right? Like you set out to have a single portal where people could go to plan out their weekends, and now it's like 400 things that are happening underneath. So this is why this feature matters. The Bedrock multi-agent collaboration enables you to assemble agents and knowledge bases under this supervisor agent that can delegate and organize the tasks. It allows you to, as a result, do more complicated things. You can unify all these different conversations that are happening across the agentic workflow. And then you have observability through that trace feature, so you don't have to go into each of these agents to see what's happening underneath the hood. And then you have all of the same stuff that we've talked about, guardrails, security, privacy, that kind of stuff. So now let's look at what this solution would look like if we updated our application to use it. So now we would have a central supervisor agent, right? A manager that everybody would just talk to, and that manager knows all of the agents that work for it. And so it can do this optimized routing where it can figure out what you're asking, and then it knows the agent to go talk to. And from a customer side, there's this great experience because there's a one-stop shop for everything. So let's say you want to make a reservation for Carbone at 7 p.m. It's a tough reservation to get, but let's say your agent's great. It can do that in the background because it knows that the restaurant expert agent is going to do that. It does that optimized routing, it talks to that, and then all you get is that output out. You can also do more complicated things, like let's say you want to plan a full weekend of activities for you and your 4 friends. So all your users are going to get is that plan out, but in the back you're going to have this multi-agent manager that knows that says, okay, to solve this problem, I have to do a bunch of things. Let's say I have to figure out what the weather's going to be like. I have to check for the things that people like to do, find events, and so on and so forth. And it'll talk to all the sub-agents that are specifically good at those things, and then it will aggregate that information, and it'll spit it out to you. And so you don't have any hard-coded paths underneath that. The agent, or the orchestrator agent, is just smart enough to know which agent to go talk to. And so if we sort of double-click into that, we'll see something like this, like it's say, okay, step 1 was getting the weather. Okay, so I have to get the weather for Saturday and for Sunday. Okay, so on Saturday it's going to be 95. It's going to talk to the weather agent. Then step 1.2, okay, I got to figure out for Sunday, scale the weather agent. Okay, cool. Now I know the weather is going to be hot. Let me find some stuff. The user likes to wakeboard. They like to dance. They like to golf. Okay, cool. I know what they like. Step 3 will say, okay, it's too hot for golf, but maybe some activity would be like wakeboarding, which is refreshing, or movies or wine tasting, which are indoor. And that should say step 4. But step 4 would be like, let's see what's happening, and then it would figure out what's happening, and all of this stuff it would execute all the way and talk to whatever agents that it needed to underneath the hood, and then all you would get out is what you care about. So I hope this kind of illustrates the point of how multi-agent collaboration allows you to scale your agents in an easy to manage way, because sort of scaling it like horizontally through just a bunch of different applications doesn't work. And then if you just try to scale one agent vertically by just making it like do everything, it's going to get confused. So that's why this approach of collaborating, getting agents to talk to each other works really well. And if you execute this really well, you can build out an application that does a bunch of stuff, right? Like you can turn this into, let's say, Nimbus Vacation Planner, and then you have a bunch of different agents underneath it that can do things like booking your flights, looking at your calendar, checking out what common scams are happening in places that you're visiting, figuring out your transportation underneath the hood. And And so you can build this like very big application that is very complex, but where you're not having to figure out hard-coded routes between all these things to talk to each other. So from a development perspective, your work gets really easy. This is sort of like just an interesting example. Like, I would use this. Like this is, if somebody wants to build this, I would definitely use this. But this is sort of just a silly example that I came up with. But Gartner said that by 2026, 80% of enterprises are going to be deploying generative AI-enabled applications. And other businesses that are using generative AI today, they're seeing productivity improve by about 30%. So as this trend increases and we're getting more and more agents out there, you're going to want a solution that makes it really easy for agents to be able to talk to each other and to build your complex applications. And I think that Amazon Bedrock is a great place for that. I'm going to transition it to Jeremy to actually show you what Bedrock looks like and a demo. So.
Well, he's going to kind of just ask a quick question.
Yeah.
So how would you compare this to like a Crew AI? I mean, which is also multi-agent collaboration, but it is more of a toolkit. Is Bedrock more GUI-based? How would you compare it
Well,
to other agents?
I've never used Crew AI, but I can speak to the Bedrock just simplifies the undifferentiated heavy lifting, right? Most companies aren't in the business of building agents, and so they want this simplest experience, right? So you have, you can build it in like in the console on the browser if you want, or you can build it in the CLI if that's easy for you. But there's this whole, infrastructure that has already been built by AWS to make building stuff in the cloud easy. And so I'm not familiar with Crew.ai, but I would say like that's the business case for Bedrock.
Probably want to check
I'll
it out.
say Crew, Crew, and then you have LangGraph, LangChain, right?
Yeah, yeah.
That also build agents. Those are
N8N
they're-
too.
hmm?
N8N.
Well,
Low-code
Swarm.ai,
agents.
there's a bunch of them.
There's a bunch, and we released something very similar to Crew AI last, it was Friday afternoon, called Strands.
Oh.
Very similar. It's an SDK. It's that integrates. It's more open to different models and different providers. I would say, this is more a managed service. It gives you a GUI
Okay.
within the console. We also have SageMaker Unified Studio, which now incorporates generative AI, so you give it and integrates with your identity provider. So you can actually give an interface to your users, right, business users, to go and build your agents without you as a company or venture having to go and build or write any kind of code to build out agents.
So it's low code.
Yeah, or no code if you're going to use the Unified Studio. So I'm gonna walk through a demo. I tried to keep with the theme of Toy Story, as just for the fun of it. So I have Bo Peep. Bo Peep is going to be our supervisor agent. The overall use case is going to be taking a legacy application, right? So for our example, we have a legacy Python Flask application that's just fronting an API to a to-do list application. I'll show you the code of what that looks like. So we have Bo Peep as our supervisor agent. She's herding the sheep, right? And organizing and orchestrating everything with all the other agents. I've got Woody, who's our legacy code cowboy. He's going to analyze the legacy code, identify any technical debt, and he's going to respond that back to Bo Peep. Buzz Lightyear's our modernization ranger. He's going to do some analysis on the code and what Woody's review had, suggest some modern patterns, propose the AWS services to help implement the application, and then send that back to Bo Peep. She's also going to then go to the toy soldiers. The toy soldiers are going to look at integration and infrastructure, and they're going to build out confirmation infrastructure as code, so that we can deploy this to AWS and kind of not have that monolithic legacy application and have it run cloud native and get all the scalability, security, and all the other abilities you get being in the cloud. So let's take a look. I think we'll start in the Bedrock console. So I've already got these agents out there and deployed. I have a Jupyter notebook created for it. Happy to share that if anybody wants the example. But this goes and deploys all the agents, and we'll run one of the agents on here in a bit.
You said you can share the notebook later?
Yeah, I can share it. I can upload it to GitHub somewhere. So here we have our Bo Peep orchestrator. So you have a couple options when you're building the agents in AWS. You can build it in our UI, putting the prompts in there, picking the models and all that. That lets you kind of play around, do your testing, but we also have the option of you can put it in your infrastructure as code using CloudFormation or CDK or Terraform or your choice provider there. Or even with the notebook, it's all API calls using our SDK. But I'm just, for the sake of kind of demoing and showing, right, an agent essentially consists of the name, you give it a role, so the role gives it basically the keys to what AWS services it's going to have access to do things with. You give it a model, so for this one I'm selecting Cloud 3.5 Sonnet. That's one of our most performant and most intelligent models that we have on Bedrock. And then you give the agent instructions, right? So this is our supervisor agent. I'm telling it, you're Bo Peep, you're a supervisor agent for a code transformation project. Your role is to orchestrate the transformation process, yada, 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 right? So it tells you that you have access to an S3 bucket. That's where I put the legacy code. S3 is essentially our object storage solution. So it stores files at scale. I tell it what tooling I have, I tell it what agents it has access to, and kind of how to run things, right? So it has kind of its directive as an agent of what to do. I give it an action group, right? So what does it have access to? Well, it has access to do file system actions within S3. So it can list files, right? So what files are in that directory. It can read files, give me the contents of a specific file, and it can write files, right? So when it goes and does all of its analysis, it's going to generate new files for our modernized app, so now it can write those files. So those are the three basic tools that I've given it. Right, so that along with the model, the prompt, that's how our agent's going to run.
So that's basically how we would load like a tool call for any LLM?
Yeah.
You said, so you can give him also access to like, hey, make an API call or whatever it is, or it's just within the Amazon?
So the way that we do good question, because I didn't get to actually talk about that. The way that we actually give it access, right? So we give it kind of a schema. There's two options, right? This is more easier to read, the action groups. You can also, if you have an open API spec or a Swagger doc, you can give it the Swagger doc and it'll directly understand kind of the API calls. And the way that it calls an API is you give it a Lambda function.
Oh, okay.
So basically, here's the schema of all the tools you have, whether it's, us using these function action groups here or the Swagger doc. And then we'll call that Lambda function, passing in the event saying, here's the tool that I want to use. Right, and it gives you like all the parameters. So when I say list files, I have to have a directory, right? So there's parameters that goes in there. So the model makes sure that it understands and knows and has the parameters it needs to go and do what it needs to do. And then that Lambda function is what's going to be kind of between the model and any tools that it has access to. So if it's calling an API, right, you need that Lambda function to have API keys or whatever security is built in. So you're not giving the model just willy-nilly access to do whatever it wants.
Okay.
Yeah.
Yeah. Is this really working with the Swagger file Open API specification? Because there was an InfoBip event a couple of weeks back, and I was talking to, I think it was Robert Jones, if I'm not mistaken, from AWS, and I was asking the same question, and he said that it's still not available fully because you cannot upload the Swagger file or send a link, for example, to the deployed version and leverage setup, for example. Those methods are available to be called by LLM and those are not. Is it really
Yeah, this is all, everything I'm demoing is generally available, works. Okay. The Swagger doc, it's really, Swagger I think is 1.0, it's Open API Spec 2.0 is what's supported. That's fully supported.
The first version is not supported, yeah?
Mm-hmm.
The version 3 and...
I'm not sure about that. I know 2 for sure.
Okay.
And I think 1 is backwards compatible.
MCPs integrated already?
Not yet.
Not yet?
Not yet.
It's coming though?
I can't
Have to be.
I can't talk about our roadmap in a public session. But if you have an AWS account team, you can talk to them and get the roadmap. But
It's inevitable that we're going to
yeah,
have to.
I mean,
Yeah.
but we do have. There is
Because I
something
built
called
something similar to this to manage like a ClickUp operation. So all we have to do is give it that ClickUp MCP and save us hours of setup. So run the
MCP is
function.
basically these function calls instead of me going and kind of listing this out for every agent and defining these for every agent. I put all of them in an MCP, and I would just say this agent connects to this MCP server. You can do that with our SDK using inline agents, which are kind of not defined in the console. They're just real time. Here's the agent. I'm defining an agent in code real time, and then I can call the Bedrock service, and it'll like ad hoc create an agent, invoke the agent, and do all the things that the agent needs to do. You can do that with MCP now. We've provided libraries for that, but direct integration with the agents defined in the console are not available with MCP yet.
I don't know if we're gonna get to that, but one last question. This orchestrator would be able to also create its own agents on the fly? So thinking out loud, like, here's a task, go create the agents you need to complete it, and give it back
It's
the
entirely
results.
possible to do that, yeah.
Yeah,
Yeah.
sure.
You'd have to have a tool that would be the tool that would end
That
up creating
creates-
it.
yeah.
But that tool, and then get that tool access to, you know, the Bedrock service to create, but yeah, that's entirely possible.
Security risk though.
Yeah, I mean, I'd be able to, yeah. That's why you have identity and access management, IAM roles attached to everything. It's attached to that Lambda function, so the Lambda function is very limited in scope of what it can do. So that's my Bo Peep agent. Well, I wanted to also show, sorry. We also have, I don't have it for this example, but we have knowledge bases. So that's your ability to vectorize and store your documents and data and knowledge so that you can more real-time ad hoc give knowledge to the model when it needs it. So if I had, you know, like vacation planner, I think your example was, what are the activities that I like to do? I can store that there and not have to pass it into the context. You only grab that context, or add that to the context of the model when it's needed.
Like recommendations for airline, things like that.
And then here's my orchestrator. Sorry, not orchestration. I'll just show this because this is, I guess, a more technical talk. So I'll get into some of the details. But when you create the agent, right, you're typically just giving the agent, right, here's the instructions for the agent. When it gets to the chain of thought reasoning, the react way things kind of the reason and actions, all that, we have the prompt templates already created for you, but you have the ability within here for the pre-processing, for the actual orchestration, knowledge-based response, post-processing, right? These prompts are provided for you by default. You don't have to worry about them. But if you are really needing to override things, or if your use case is very specific, you can go in here and change the prompts here, so that your agent is very much like aligned to what you're doing, right? So that all of that's overrideable. So you have full access to everything, and there's visibility and traceability to everything that the agent is doing. There's no black box when it comes to what the agents are doing behind the scenes. And I'll kind of show that when I run the demo real quick.
The prompt you refer to specific S3 bucket. Will it
Yeah.
recognize?
Yeah, yeah. It's defined as in the Lambda function that it's going to call, it's defined as an environment variable. And then the IAM role attached to that Lambda is only allowed to touch that bucket.
So you cannot provide any bucket input.
You could, but I'd be, you'd want to be scoped to where it's like doing what you want it to do with the buckets you want. So here's kind of like with the orchestration, right? The one we've been looking at is Bo Peep, right? That's our workflow orchestrator. And here's where it's been defined that, hey, you're Bo Peep, but you also have Buzz, the toy soldiers, and Woody available as collaborators as well. So Bo Peep is defined as a supervisor. The other three are the collaborators. Here I can define a couple different things with the multi-agent. Here I'm just turning on multi-agent collaboration. Supervisor and supervisor with routing, right? So Bo Peep is a supervisor, meaning that agent is going to send things to the sub-agents, but also those sub-agents are going to return to the main supervisor, and the supervisor is going to do all the orchestration in response to the end user. Supervisor with routing is saying, hey, similar to maybe Salman's, I'm going to be the supervisor, I understand all the sub-agents I have, but I don't, maybe for the purpose of speed, I don't want to return to the user. I want to pass the query or the end user's request to that agent, and that agent is going to be the one responding to the user. So I'm routing to an agent, that agent is going to be the end response, right? So there's not another hop back to the supervisor before response. So for this use case, I need all the agents working in conjunction with the supervisor, working with them, so I do that. That's supervisor. And then here I'm defining, right, what's the agent, and then within each agent you have aliases and you have versioning, so all that's kind of built into the service. And then what's the collaborator, what are the instructions, and then enable conversation history says, hey, I can take everything that was previously said and pass it to that sub-agent so it knows what's going on. So that's kind of our setup, right? We have those 4 agents, 1 supervisor, those 3. I'm gonna show.
Let's say we want to pass just like a summary of the history, then that would be like in a function. Summarize it and then pass it to the agent. Because sometimes we have such a big context, right?
Yeah.
So we want the sub-agent to know what's going on, but we don't
There.
want to extract over the 128,000 tokens. So how would you be able to like give it to him? Just as a function, I'm assuming?
I'm checking. I'm not sure what your reader was. Might be this memory. There is a way to do that built in where the model will automatically just summarize and pass the summary across. For the use case of this, we want the whole context pin over. But you could, I guess, in your prompting to the supervisor say, hey, just summarize at where you are at the moment. Don't send the whole context, send some of it. You would turn off the sending the whole thing over and just have the model itself pass the necessary information.
But most of the tokens anyway, right?
Yeah, it will consume tokens, it will slow things down.
But you also showed there is some pre-processing, post-processing. In pre-processing, does it make sense to actually do this summarization steps?
You could, yeah. Depends, I mean, it's gonna depend on your use case, how fast you want it to run. Is a user sitting there waiting for it? Is it something that can be more asynchronous to run?
Good question though. If the agent is the one replying back to the user, the supervisor is essentially more like a dispatcher than a supervisor, right?
Yeah.
Okay.
Withdraw, yeah. So I'll show this. What I have here is our legacy app, right? So it's a very simple, it's a Flask app. It's got an in-memory to-do list array, and then it's got a bunch of APIs for the to-do list. It can create items, get items, and delete items, and edit items. Very simple app, monolithic, can run on a container, can run on your laptop, whatever, right? So what I'm gonna do, and I have that app.py here in this legacy folder here in S3. So one thing I can do is, let's do just a simple request, right? Please list all the files in the legacy directory.
Too
It took
long,
3
no?
seconds, I think. I'm wondering if my
To
token
just do an LS?
I think my token tagged out. I refreshed it. There we go. Don't know what happened there, but here's a, please read the contents of app.py. So this is reading our legacy app. So what I've done is the trace, when you look at each trace event coming back from the API, it's very verbose. So I have a function that's kind of just helping us summarize what's going on. So here it's processing the request, it's doing some reasoning and thinking. Here's a tool call, right? It's saying, hey, I want to read this file. It's called app.py, it's in the legacy directory. Here's the tool result being passed back. This is all happening within the supervisor agent because I don't need a sub-agent, it's a very simple thing. And the supervisor agent has access to the tools. So then it thinks through, okay, now I have the contents, here I'm gonna make a response, and then here's the response to the user, right? Here's what's in that file. And it actually summarizes what's in that file for me, because it actually can read and understand the code. Simple enough, and then I had a couple other examples, create a test file so I can test that I'm writing. Here's when I ran it earlier today, right? It just, takes a few seconds, 8 seconds, and it wrote a file. Now I want to test the modernization process. So here I'm saying, please analyze the legacy application, coordinate with your specialized agents to create a modernized version of the app using AWS Lambda and API Gateway. So those are our serverless services for APIs. In CloudFormation, which is our infrastructure as code solution, and then store the modernized files in the modern directory in S3, right? So that's the extent of the prompt. And I'm gonna run that. It takes a little while, but what we'll be able to see in real time is the coordination between all the agents, right? So first thing happening is the supervisor agent has the request, and now it's processing and trying to figure out with the chain of thought reasoning what it's gonna do next, right? What agents do I need to call, what do I need to do? So now here's the reasoning and thinking coming out of it. I'm gonna coordinate a comprehensive analysis with modernization efforts. We're gonna break this down into different steps, right? So the steps it has first, I need to ask Woody to analyze the legacy code patterns and identify areas for improvement. Simultaneously, I'll ask Buzz to propose the AWS serverless architecture patterns. Then, at the end of that, I'll ask the toy soldiers to prepare the infrastructure as code. So what it's saying is, it's going to have Woody and Buzz, right? One is analyzing the code, one is analyzing what the code should be for the future, like more modernization. It's calling those two in parallel to save time on everything. Once it has those responses back, it's going to send it to our modernization kind of integration experts to go and generate all the code and everything needed to modernize that.
How you got it to do it in parallel? Through your hard coding?
So when it does the tool call, it puts two tool calls in that request path. So then basically the engine behind Bedrock processing things knows that it can call these in parallel instead of sequential.
It's actually great, it saves a lot of time.
Yeah. And that's in that default prompt I showed you, it's in there, like how it knows that it can do things in parallel, it can do things in series. So when it comes up with its React chain of thought, that's all there.
What about synchronization? Let's say, for example, I have 5 parallel processes, and my next step depends on completion of all 5.
The supervisor agent will be the one receiving those events, and then it waits till.
I mean, the supervisor is responsibility to supervise not just speed, but also connect the results and wait for the results.
Because it's not doing the routing. If it was doing the routing, it would route to them and let them respond. In this use case, it needs the responses to come back, and the supervisor knows. And actually, the supervisor won't even get all the responses until they're completed, because it told Bedrock, hey, I need these two to run in parallel, or however many in parallel. When all of those in parallel are finished running, that's when the response will get back to Bedrock, or back to the supervisor. So the supervisor's not even just, it's waiting, but it doesn't even know it's waiting.
So Bedrock is collecting all the data, and here you go.
Right.
Another question, what happens if you need one step to be optional? Do one of those 4 and 5 or 6 steps?
The supervisor's gonna have to figure that out. So it should have the logic it needs, and it's gonna have to make a decision. Because Bedrock's, like the service for the tool calling is gonna do what it's told to do.
Okay.
So the supervisor, that's kind of its job. So it's still running, but you can kind of see all the different back and forth, supervisor to Woody, supervisor to Buzz. It's analyzing, right? Here's an actual, the modernization comes back with this analysis. Here's the services we should use, right? It actually says, hey, I'm going to use a NoSQL database for the to-do items instead of me having it stored in an array that's going to go away anytime I restart anything. It talks about the API layer, the compute layer. So it did a full analysis of that simple, Flask app that we had. Here's the modernization saying here's the actual code that I want to write. So here's the code, but it's also calling the tool to write that file. Right? So when I go back to S3 and I look in the modern folder, we're going to see that all of these files are starting to be created. Here's the toy soldier integration. So that I can tell by looking at this, right? This is a CloudFormation. So this is saying, hey, I'm defining a table. Here's the table that I want to have. It's called to-dos. Here's my API gateway because I need an API. Here's the different API resources, right? So this one is the path to-dos. It'll define them as get, post, different API path there. Here's, it's very robust, and it's defining the entire CloudFormation script. So this is actually runnable at the end. Here it's defining the Lambda functions, right? So the things that are actually going to run the code to kind of return them the API. So it's doing a lot of work while we're here waiting and talking. The integration is like now making other tool calls, it's writing other files for the requirements. So all the dependencies that Python needs. And now the supervisor agent, I think there was a bug in this that the integration agent is writing files, but the supervisor also thinks it needs to write those files, so it's taking a little bit longer. So there's some prompting that can probably get fixed. But now if we go here to our modernization folder here, right, we can see that it's creating all the files we need, right? So here's the template, here's the difference. The template is the CloudFormation YAML template, and at the end, one thing I asked it to do was create a README file. So if I open this README, so this at the end, this might be from earlier, but it's going to be the same thing in the end. I asked the supervisor agent to kind of summarize everything that was done and create a README file that I can put in my code folder. So here it goes and defines the architecture, and I gave it very little prompting on what the README should be, other than just, hey, document what you did. So it comes up with, here's the architecture, improvements on the legacy version, here's the things that it did to improve it. These are the API endpoints defined in the end solution. Here's how you deploy it. It actually gives me the command line commands to actually get the Python dependencies installed and also do the deployment of the CloudFormation template. Talks about error handling. So it's pretty cool that it's actually very robust that it went and did all that.
Good questions.
Did I miss anything?
Yeah. You have two questions.
Yes.
First, this is just a code. In other words, it's not testing code, right?
This solution?
Yeah.
Yeah, this is just me like trying to get a Toy Story themed demo that kind of would resonate with a more developer oriented crowd.
Yeah, it just generated, but was not kind of tested through real environment and then
No.
part of the testing. Yeah, thank you.
Yeah,
So second question, what stops me to use the same prompts, but just on cursor locally, feed my code and say, okay, just generate it for Google Cloud or for AWS or for Azure this solution. Any limitations? In
No.
other words, what is so specific in this environment?
I specifically tell it AWS,
Got it.
and I tell it serverless so that it's focused on like serverless technology. So it's going to focus on Lambda and API gateway, those kind of things.
So it's just a matter of prompt and targeting the platform.
Yeah, and I told it CloudFormation. It could have done Terraform. It could have done CDK. It could have done any of the, the models from what I've seen are they know the different cloud providers. They know how the resources work. They know the infrastructure as code paradigm and how to write things like that. So.
So, question is, how do you charge for this? In addition to the token cost for the LLMs, which presumably, do I pay that separately because I give you my API key, or do you do that, and then how do you charge for the stuff you put on top of the LLM?
So we don't charge for the orchestration or the things happening within Bedrock. We only charge for the tokens when it comes to agents.
You mark up
but
the
the
tokens?
construct is within the account, right? So I have an account, an AWS account. This is all running in that account. So all the charges roll up to that account. And when the agent's running, the only thing you're charged are tokens into the model, tokens out of the model. Or they're charged, like they're a little bit different each way, but
Okay, so you guys, if we use the Anthropic, you're going to probably charge a little higher than what I would get from Anthropic for a particular model.
so we charge the same as Anthropic.
So basically, it's free.
The agent doing all of this work.
All this
is
stuff is free because I'm paying the same as I would if I did it myself directly with Anthropic.
Yeah.
I'm paying the same.
One thing you will pay for with the tool use that I'm calling that Lambda function, you're going to pay for that Lambda function, which
Okay.
is
And the
like
S3.
0.00000 cents per millisecond. It's like
I think you have like a huge free tier for Lambda functions, no?
yeah.
Yeah.
Within your first 12 months, I think you get a pretty decent amount.
And then the S3 is probably cheap depending on what you're doing.
It's like 10 cents a gigabyte per month.
Yeah.
Off-topic question, just on the lazy side, let's say, for example, OLM generated the source code new project, cloud native, perfect. Is there a way to test? Just ask it, okay, now go ahead and use AWS and run all this CloudFormation scripts, build the environments, run the code, find the bugs, give me them.
So what I would do there is use Bedrock flows.
Bedrock what? Say it again?
So we have something,
Floats?
so I guess the ask, right, is we've had this agent, or these agents run. They've taken this modern app, or this legacy app, and created this modern app, right? So it's got code, and it's got infrastructure as code to deploy it on AWS, right? It should be a fully ready solution to deploy that. If I deployed that right now, saying that all the syntax was correct, within, say, 5 minutes, I would have an API gateway, so I'd have a public API endpoint that would give me access to a backend DynamoDB database that has to-do apps for creating, deleting, modifying, just to-do list things, items, right? Say I have that now, right? So what would the next step be if I wanted to test it or deploy it, right? One thing would be, hey, can I just check it into Git and then have a GitHub app, maybe have it create a GitHub action that would go and do that deployment, right? I could also do a flow, right? Because I would say the agent is, these agents, like as they are specific enough, I wouldn't want to add too much more to them. But I might say, hey, these guys are going to do this work to create this code. My next one would be, after these agents are complete, I might call another set of agents that are specific to my actual deployment. So maybe that's where I generate the, whether it's like a GitHub action or whatever your CI/CD pipeline solution is. Maybe it's going to go and generate that pipeline, go and deploy it to a test environment. Within the CloudFormation, you get outputs, right? So that pipeline can take those outputs and maybe run some unit tests on them or some system tests to see, does this actually work? Right, so you can orchestrate an entire kind of suite of things to go and build, test, code, all that. The more complex you get, the more you're going to need to iterate on it.
Yeah, we're not in those days like, hey, make me the app and it actually works.
I think there would be a lot less people in this room because we all had a job, so if that was all working well.
But questions about the tokens.
Yeah.
So when we're orchestrating it this way, we're really increasing our access to the limits, right? Because each agent will have its own context window,
Yeah.
and as it's writing files, is it dumping the history of what he wrote, or it's still keeping it in the context window?
In this use case, I was passing the history, the conversation history, so it's passing all the tokens. So a larger application might hit, because I think the input limit for the model that I'm using, the Claude Sonnet model, was 200,000 tokens, which is a decent amount.
Yeah.
But over time, through iteration, different files, it's going to build add up.
But if we could tell each agent to operate as a standalone, you could actually write a lot of files.
Yeah.
If you have a problem with tokens, but if, like Google was mentioning with their premium tokens, if they solve this problem, you don't have to even worry about it.
Yeah, if you could know the entire software by heart, yeah.
It is kind of
Yeah, I think our Nova models, I don't have the quotas here. Our Nova model, I think, have a 1 million token limit for some on the input. So, but Claude 3.5 Sonnet and 3.7 Sonnet is not available yet for the agents, but they're incredible at coding. So,
Yeah.
that's
Yeah,
why.
I've been using them in Windsurf and amazing results. Especially if you give it like a very detailed PRD feature request, how everything should behave, and then you break it into tasks,
Yeah.
they're able to accomplish
This
it.
whole demo was vibe coded with
Yeah.
3.7 Sonnet.
Okay.
It's me,
This whole demo.
don't share
Yeah.
secrets. Because you-
Really?
I mean, you have to iterate. It's not going to go and generate
But
everything I want.
still, I mean, wow,
Yeah.
okay.
Yeah. Someone didn't create any of those slides. That was all.
Yeah.
Okay.
No, I actually did use something like that.
Do you have a lot of examples of people having agents that say contradictory things? Like people having agents that give different advice and then they conflict and then how to resolve that?
I haven't seen that. What I have seen somebody do recently, and I started doing this, right, in their prompt, they will, because the agents want to appease you, right, so they want to just, do what you want them to do. They won't question you. I saw somebody put one of their prompts for one of the AIs they're using, like, question everything I'm saying, ask more detailed questions, say no if things don't make sense. And he added that into the model. And he found that the model was pushing back a lot more on things that it should have been pushing back on instead of just being a yes man and just, responding however you wanted it to respond.
There's also an interesting use case I saw around stock trading,
Right.
where you have two separate agents with two different strategies, and then you can sort of they're kind of competing, right? And then whoever's doing better is the strategy.
Right, but then who is, or what system is deciding the better? Is that like, is that something that you manage at the supervisor level, or is that,
Well,
or
I
they just
think-
get back to responses with both individual agents?
In that case, it was money, so you want like a person, right? But like, I'm sure that in the future.
No, but the dream is to
Yeah,
build a
exactly.
money-making machine,
Right.
right?
There you
Like-
go, that's the money